What is going on, guys? Welcome back. In this video today, we're going to learn how to generate structured output using large language models in Python. Now, what this basically means is that we can define a so-called response model, or we could also say a schema, that specifies exactly what kind of output we're expecting from the large language model. So instead of just accepting any response, any text, any JSON object, we define exactly what we want a model to return. For example, a person object that has a name, which is a string, an age, which is an integer, a birthday, which is a date, something like this, and then the model has to stick with it. And we're going to learn how to do that in Python because this is something that is extremely useful and sometimes even necessary, because if you can trust the output of the model to match a certain schema or to match a certain data model, you can just go ahead and use it right away without doing any fancy post-processing. So this is what we're going to learn how to do in this video today. So let us get right into it. Alright, so we're going to learn how to generate structured output from large language models in this video today. And for this, we're not just going to use a feature of one of these APIs of one provider. We're not just going to use the OpenAI API that allows us to do that. We're not just going to use some Gemini feature that allows us to do that. We're going to use a Python package, and we're going to apply the same approach to all the different model types. So we're going to do that with OpenAI models. We're going to do that with Anthropic models. We're going to do that with Gemini models or Google models. And we're also going to do this with a local Ollama installation. So when I run Ollama list here for this video today, I'm going to use Qwen 2.5, 1.5 billion parameters. So a very small model. It's not going to be very capable, but we can apply the same approach to our local model here as well. So we're going to use a unified approach, you could say, and there's also other model types that are supported by this approach or by this strategy. So there are also other models that we can use this strategy with. And this strategy or this approach is installing a Python package called Instructor. So we're going to say pip or pip3 install Instructor, and this package allows us, or this package wraps itself around the various clients and forces, so to say, a structured output. So we can define a response model or a schema using Pydantic. For those of you who don't know what Pydantic is, it's basically one of the most used libraries for validation, for schema validation. And it ensures essentially that we get what we expect. Now, sometimes this will fail, and even after retries it will fail. Then it's going to raise an exception, but it will either raise an exception or give us what we're expecting. Now, before we get right into the implementation, one or two words about the setup. I'm going to show you how to do everything here from scratch, except for two things. I'm not going to show you how to install Ollama. This is quite straightforward. You go to the website, you run the curl command, and you basically have Ollama on your system. Then all you need to do is you need to say Ollama pull and a model that supports tool calling. So it's actually quite simple to do that. I also have a video on this channel on Ollama. So if you want to do the self-hosted approach here, if you want to try structured output using your own models on your own system, just install Ollama. I'm not going to cover that part. And what I'm also not going to cover is getting the API keys from the various providers. So you can use that, as I said, with Anthropic, OpenAI, Google, or Gemini, and also other providers. I trust you to be able to get those API keys yourself. The only thing that's relevant here is where you store these API keys. So my setup is the following. I have a .env file here. So a file where I have key value pairs essentially, or environment keys and values stored. Basically, the file looks like this. I'm going to create now just an ordinary env file. It's basically OpenAI underscore API underscore key is equal to, and then I have the OpenAI key, whatever that is in my case. Then I have the same thing here for Anthropic underscore API underscore key, same idea, just some key. And then I have the same for Gemini underscore API underscore key and whatever the key is. So this is what my .env file looks like, and we're going to load that into our script so that we can easily use the various clients without having to constantly pass around keys. So that is my setup. In my case, as I said, it's not env, but .env, and I recommend you do the same, or you can also just specify them clear text in your application, which I would not recommend, but for experimentation purposes, you can do that. So that is my setup. And of course, you don't need all these API keys. You only need the API keys that you actually want to use. I'm going to show you how to use it for all the different models here, but you just need to include the models that you want to use. So let us get started by opening up a file and let's call it main.py. By the way, other dependencies that we're going to need for this video today, since I did not mention those, we're going to install here Pydantic, obviously. So pip or pip3 install Pydantic, and we're also going to install OpenAI. We're going to install Anthropic, and later on we're going to also install something for the Google part. But for now, we're going to install it right away. We're going to say Pydantic, OpenAI, Anthropic, and we're also going to install Instructor. But in the square brackets here, we're going to pass a certain dependency or specification, which is Google-generative AI. This is important because this allows us to also use Gemini with Instructor. So this will install the package that is needed. Just run this. Also install, as I said, Pydantic, OpenAI, Anthropic, and I'm also going to use python-.env. So let me maybe just run this and then scroll up again so you can see that. This is the command. pip3 install Pydantic, OpenAI, Anthropic, python.env, and also, as I said, Instructor with the dependency of Google-generative AI. I think this should cover everything. The rest is core Python. And we're going to start with a very basic OpenAI approach. So we're going to use the OpenAI API. And to be precise, I'm going to use GPT-4o. And we're going to generate structured output. Now, let us start with a very simple example. So I'm going to say here, import, or actually from Pydantic, I want to import the base model class. This is going to allow me to define my schema or my data model. Then I'm also going to say from OpenAI, import OpenAI like this. And then I'm also going to say from instructor, or actually do I need, no, I don't need from, I just need to say import instructor. And basically the idea now is I create an OpenAI client and I wrap instructor around it. So what I do is I say client is equal to instructor dot from OpenAI. And then what I do is I pass an instance of OpenAI in here. So I just create an instance of OpenAI. This is automatically going to load the API key from the environment. Now, in order for this to work at all, we need to load the environment variable. So we need to load the .env file. How do we do that? We do that by saying from .env import load.env. So this is the python.env package that we just installed. This is going to allow us to just call load.env. This is going to take these key value pairs from the .env file, and one of them is going to be the OpenAI API key, which is going to be recognized by this already, and I'm authenticated. I can use my credits in the API, and then I wrap the instructor around that. So let us define a very simple data model. Let's just say I want to have data model here, which is going to inherit from base model. And I just want to have a simple person object. So let's say my model includes a name, which is a string. It includes an age, which is an integer. Then also a birthday, which is dt.date. For this, of course, we need to say up here, import date time as dt. And let's also say, let's say we want to have a gender, and the gender is going to be a string. Now, I can do it like this, or I can also use some more advanced features of Pydantic. For example, I can go up here, I can say import field, and then I can say the gender is equal to field, and then I can provide 3 dots here, and I can say description is equal to, and I can pass a string describing what kind of field this is. So of course gender is gender, but maybe I want to have specific formatting here. So I can say either M for male or F for female. Now you need to keep in mind, this is of course not how you write female. You need to keep in mind this is just a hint. This is just text describing what this feature is. This is not a constraint. So the only constraint that the model has is that this has to be a string. In no way am I constraining the model to either be M or F. If I want to do that, I would have to use an enum, which we're going to take a look at later on. But for now, this is just describing it, and we're trusting the model to use either M or F. But of course, the model could also provide K or female or male or something else, and it would still be accepted by Pydantic because it's not violating the schema. This is just a hint. But I cannot pass, for example, a number as the birthday or a string that is not valid as a birthday. It has to be a date object. So how do we now get an output? I can just say now response is equal to client.chat.completions. Come on, completions.create. And here now I have to pass a couple of things. First of all, the model I want to use, in my case, GPT-4o. Then I want to have a message history. So I'm going to say messages is equal to a list. And then I want to have one starting message here, which is going to have the following key value pairs. The first one is going to be the role. And this role is going to be user. And the second one is going to be the content, so whatever this user wrote, and our prompt is going to be something like Mike was born on April 4th, 1990, for example. Now, as a context, since this model is not connected to the internet, we're going to just provide the current day. So I'm going to say today is, so we need to make this a formatted string just to be fair, because I'm expecting this model to calculate the age. And because of that, I'm going to provide the current date. Otherwise, it may hallucinate a date. So I'm going to say here today is, and I'm going to pass dt date today. And then I'm going to say, what am I going to say? Fill the data model based on this information. Now, of course, what the model could do, if I don't specify any model or any schema, it could just hallucinate anything. Also, of course, I could specify the schema here as text. I could say, I'm expecting a name that is a string, I'm expecting an age that's an integer, and so on. But I cannot force it to do that. I can always request to do that, but the model can just do whatever it wants and violate my expectations and not do what I asked it to do. With Pydantic, I'm enforcing that I'm going to get whatever I'm looking for. So either I'm going to get what I'm expecting, or it's going to raise an exception. So for example, we are going to see that this is possible to simulate if I, for example, deliberately guided to provide the birthday as a malformed string. We're going to take a look at that in a second here. The most important part here is to specify response model. So to say response model is equal to data model. That is going to force the structure. So now I can print here response. And when I run this, we're going to see hopefully that this is going to return to me a Pydantic model instance. So you can see this is now a data model instance, name equal to Mike, age equal to 34, which is correct, birthday equal to a date instance, 1990-4-4, and gender was not filled. Now, I would expect it to recognize that Mike is male, even though, of course, it doesn't have to be, but I would expect it to, yeah, this time it got it right. So this time it recognized that Mike is a male, and it filled it with M. So you can see that this works. But you also see that it can provide just an empty string for gender because we didn't specify any specific constraint here. We just know it has to be a string. So let's go ahead and try to make this fail deliberately. What I can do here is I can say, for example, the birthday is a field, and the description will ask the model to deliberately provide a malformed date string. So it's going to say, provide this in the format, and then I'm gonna, I don't know, use day, year, and then month, including the parentheses. This is crucial. Now, when I run this, I'm going to probably get an exception because it's going to try to fit this into that format, and the Pydantic model is going to reject it, resulting in an exception because now the input value was 0404. It's not even the model that I requested, but yeah, still 1990, and it didn't work. And what I can do in this case to try to make this work, because maybe it can work over time, is I can pass a parameter here, max_retries. For example, 10, it's going to retry 10 times to get a proper response. If it fails, it's going to raise an exception. Otherwise, it's going to give me the data model. But in this case, probably it's going to fail 10 times. It's going to take some while, and it's going to raise an exception again. This is how you can do that as well. So there is the possibility that you're going to get no response because there is some mismatch in the description and the data model, or there's just some other problem. That is of course possible. Usually it doesn't happen. And as an alternative to that, at least when it comes to OpenAI models, you can of course also use their structured output API. Then you have a guaranteed correct output. So now what we're going to do is we're going to get rid of that, and we're going to do the same thing for Anthropic. So let's go and copy all of this. Let's go down here, leave some space. And now we're going to say client instructor, or client is equal to instructor from, in this case, underscore, is it called Anthropic? And then we're going to make an instance here of Anthropic. Now for this, of course, we need to do the respective import. So we need to say from Anthropic import Anthropic. And the rest is pretty much the same. We still need to define the model. Of course, the model is going to be something else like Claude 3-7-sonnet-latest. You need to get the correct names from the documentation. The only difference here is that we need to also specify, this is a mandatory keyword for some reason. We need to specify the max underscore, what was it called? Tokens. Max tokens. And let's set this to 1024, because if you don't specify that keyword with Anthropic, it's going to tell you that it needs that keyword for whatever reason. So let's comment all of this out to not waste tokens on the OpenAI API. And let's run the same thing here using the Claude model. Let's see if it can fill the model correctly. There you go, Mike, 34, birthday, and gender is equal to M. So you can see, quite simple, we create an instance, it reads the API key from the environment, Anthropic underscore API underscore key. It creates the client, and then we just have to specify the model, the response model, and then we get the response correctly structured. So let's copy and paste that again. Now, for the Google approach, we need to do it a little bit differently. I don't know exactly why, but the approach is just a little bit different. So in this case, what we need to do is we need to import from Google.GenAI or Google.GenerativeAI, we need to import GenAI. At least I think that was the correct import. No, sorry. We need to say import Google.GenerativeAI as GenAI. And then we also cannot just load the API key automatically from the environment. What we need to do is we need to say GenAI.configure. So we need to say GenAI.configure, and then API underscore key is equal to OS get environment, or of course here you can just specify the key right away as clear text. But in my case, I'm going to load it from the environment, which is Gemini underscore API underscore key. And then we need to say instructor from underscore Gemini. Here now we need to say GenAI dot generative model. It's a little bit confusing why we have to do it that differently for Gemini, but it is what it is. So generative model, and then we're going to say model underscore name is equal to, I'm going to use Gemini dash 2.0 dash flash. I'm not sure, do we need to, I think we need to specify models slash, otherwise it's not going to work. So that is the model that we want to use. And we also need to specify, let me maybe format this a little bit better. So let's indent this. Let's also indent this. What we also want to specify here is we want to say that the mode is equal to instructor dot mode dot Gemini JSON. So this is going to put it into JSON mode, but we still need to specify the response model. We do that by saying response is equal to client. And here now we say dot messages dot create. We don't specify the model anymore. We don't specify max tokens. We still specify the same message history, and we still specify the response model. So this is how you do it for Gemini. I hope I didn't mess up anything. If I run this now, I should be able to get the same kind of output. No, because I'm not loading OS, of course. Let's run this again. And now I get Mike, 34, the birthday, and M. Perfect. So that seems to work for all of those three. It's also going to work for Ollama, but I think the quality is going to suffer. So it's probably not going to calculate even the age correctly, because the model I have on my system is so weak and so small, it's not really going to get anything done. But I want to show you how to use Instructor for local models using Ollama. So what we're going to do here is we're going to say, interestingly, we need to use the OpenAI function and also the OpenAI constructor to connect to Ollama. So we need to say here, client is equal to instructor dot from OpenAI. Even though we're not going to use OpenAI, we need to say that, and we need to also create an OpenAI instance here. But what we're going to do is we're going to say base underscore URL is equal to http://localhost port, what was it, 11434/v1. And here now we're going to say API key is equal to whatever, let's call it Ollama. It doesn't really matter because this is not going to be used, but it's a required field, so we cannot not specify it. We need to specify it. It's just going to be ignored. And now what we do is we also specify again that the mode of that is going to be equal to instructor.mode.json. Let's use no white spaces here. And the rest is pretty much the same. So we just need to copy that. We need to paste it down here. We still have the message history. We still have the response model, but we also need to specify the model here now. And the model in my case is going to be Qwen 2.5, 1.5 billion. And if you want to use a model in Ollama, you basically just say Ollama pull and then the model name, for example, Qwen 2.5, and then colon whatever parameter size. I think there's also 0.5. I'm not sure about this. There's also larger models. The larger the model, the more capable it usually is. You're going to see that 1.5 billion is not going to perform very well, but it's going to be enough to show you that it does do something. Now, if we are lucky enough, at least to get a correctly structured output, maybe it's not even going to be able to do that, but that is not a problem with Instructor. This is, if it happens, a problem with the model and the weakness of the model, but I think it should be able to derive at least some number for the age, even if the number is wrong. Okay, I didn't get anything because I didn't print the response, but it seems that it works because it didn't raise an exception. So let's run this again and see what we get. Mike 36, which is wrong, but we get a number, and gender is correct, at least in my assumption here. So you can see this works with any kind of setup. I can uncomment all of this again and run all of this at once. We're going to see that all these different models produce the same structure. Whether the values match or not is a different issue, but we get the same structure here. You can see our local model is a little bit confused, but it's not too much off. It could also say 70 or something. So yeah, you can see this is pretty cool that we can force the output to be a certain way. Now, what I also want to do here is I want to show you a second example, which I prepared. I think I'm just going to copy paste it because I don't want to type it from scratch again, but I'm going to explain it to you. So let me just copy this. Let me remove all of that. It's pretty much the same logic, just with a couple of additions. And what we have here is we have an enum. For this, of course, we need to import from enum, import enum with a capital E. We also have type hinting use. So we need to say from typing import list and optional. I'm not sure if we use optional, but we're going to import it. And I think that's basically it. So what we do here is we ask for movie recommendations. So we have here the same structure as before. We have the OpenAI API, we have Anthropic, we have Gemini, and we have, actually we don't have Ollama because it probably won't work, or it didn't work when I tested it, so I excluded it. But essentially what we have is we have the idea that the model can respond with a certain movie recommendation based on a prompt. So what I say here is, I love Shutter Island. It's one of my favorite movies of all time. Recommend 5 more that are similar. And then I expect it to give me, this is now my response model, I expect it to give me a list of movies, where movies is another pydantic model here. So I have title, string, release year, int, and then genres is a list of movie genre enum, where I can choose between thriller, action, mystery, drama, romance, animation, and other, just so I can always have other. And what this is going to do now, it's going to give me a list of movies where movie also is a list of genres together with release year and title. And here I have a selection, which means that for a genre, I can never get anything other than one of these. I cannot just all of a sudden get fantasy or something. I will get one of these or maybe an empty list. This is also possible, but I'm not going to get any hallucination here. This is not a string, this is an enum. It's a drop-down menu, so to say. And here also, to make this model more capable, I provide a field reasoning text. This is optional, you don't have to do that, but it's going to sometimes make the model perform better because it has a space to provide some reasoning and to then make the decision to fill the rest of the model. So we can comment that out for now to see what happens. What I do basically here is I just make the request and I print the reasoning text and the recommendations. Let's remove the reasoning text here and see what the output looks like. And what I do in the output is I get the movie. Actually, what's the problem here? Oh, I think this needs to be in quotation marks. Let's see if that resolves the issue. And now you can see I get the recommendations. I get these movies recommended by OpenAI, these movies recommended by Anthropic, and these movies recommended by Gemini. You can see there's quite some overlap here. So Seven seems to be a very popular movie for Shutter Island fans. We have Inception, we have Memento, we have Fight Club. I can agree with a lot of these recommendations. I think they're good. And we can also now try to see what happens when I enable the reasoning. Now, I already think that these recommendations were quite good, but maybe we're going to get different ones here. By the way, this could include some spoilers. If you don't want to get spoiled on any of these movies, probably there's going to be some reference to certain plot twists. So if you don't want to see that, click away. But essentially now I'm forcing the model to give a long explanation of why it chose that list. You can see it takes some more time already. And here now it says, okay, I recommend this because of whatever. Maybe for something that I can judge, I can get, maybe if it goes with Inception or Fight Club. Because I didn't see the movie Seven, so I cannot really say if that makes sense. But here now it says Inception. It stars Leonardo DiCaprio. It deals with psychological themes, reality versus illusion, and so on, plot elements. So I can understand this recommendation, and I can also understand why the model chooses this recommendation. So you can see you can do quite a lot with that. These are quite simple models. You can have nested models. You can have models inside of models, enums. You can have dates and lists and optional fields. You can also say, for example, here, optional for that. And the cool thing about getting an instance of your response model is that you can take it, trust that it's exactly the model that you're expecting, and you can feed it into the next function or into the next step of the process, which is oftentimes, as I said in the beginning, very useful. Sometimes it's necessary. But this is how you can do that in Python. Maybe just a brief explanation here, because I noticed I didn't explain what we're printing here. What we get as a response here is an instance of our data model. So this is an object that we can access attributes of. So I can go to response.reasoning text to print the reasoning text. I can also say for movie in response.recommended movies, because this is a list of movies. And then I can take an individual movie and access the title, release year, and also in this case, I can then one more time iterate over the genres of the movie, and I can get from the genres the name, which is in this case an enum attribute. I can get the name. I could also get the value in this case because it's the same. But just so you understand what we're printing here. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.